All right, so yesterday we got to start lesson 2.5, factoring higher degree polynomials. And one of the tools is synthetic division. I want to look at one more problem before we pick up where we left off yesterday. We were talking about the remainder theorem. We have still more to cover on 2.5. But I want to do a synthetic division problem here that you might think, if I gave this to you, that you couldn't do. But there's a trick that you can use so that you can perform synthetic division on this problem. The trick is to realize that I can rewrite this as 3 times the quantity x minus 4/3. All right? So instead of 3x minus 4, you're factoring out a 3. So now we can divide by this, x minus 4/3. You can't do it all in one step, all right, because it's not in the right form. But I could do this one thing here, and then we'll show you what you would do when you get to the end. So let's do our synthetic division now. You might think this is not going to be very convenient or easy to do, but let's just take our coefficients, 9, 3, negative 2. Notice we don't have an x to the first, so we'll put a 0, and negative 32. And I would write 4/3 here. A is 4/3. So you just do it the same. Bring down your 9. 9 times 4/3. Well, 3 goes into 9 3 times. 3 times 4 is 12. B plus 12 is 15. 4/3 times 15. 3 goes into 15 5 times. 5 times 4 is 20. 20 minus 2 is 18. 4/3 times 18. 3 goes into 18 6 times. 4 times 6 is 24. 0 plus 24 is 24. 3 goes into 24 8 times. 4 times 8 is 32. Minus 32 gives you 0. But we're not dividing by. Now what's important for you to realize, we're not dividing by just x minus 4/3. You're really dividing by 3 times x minus 4/3. So we divided by x minus 4/3, so now you got to divide by 3. So if you divided each term here by 3, you're going to get 3, 5, 6, 8. And your remainder is still going to be 0. So that's your remainder. That's your constant, x to the first, x to the second, x to the third. So the division here would actually be, if you took this and divided it by this, your answer would be, now this is kind of an aside here, so that's not part of my answer. You would get 3x cubed minus 5x. No, actually that would be plus 5x. Plus 6x, or 5x squared, that is. Plus 6x plus 8. That's what you would get if you divided this by this. So we could do synthetic division, only though because I factored out that 3. And so I really am not dividing by 3x minus 4. I'm dividing by x minus 4/3. And then when you get your answer, you still then need to divide by 3. So that's something that you might be able to do sometime. I don't believe there are any problems like that in your homework where you need to do that. And I don't believe there are any problems like that on the test. But I'm not guaranteeing. I'm just trying to look again at your homework and see if there's anything like that in your homework, and I don't think there is. But that is one thing you could do if your leading coefficient is not 1. You could factor out whatever the leading coefficient is. And as in this case, you might wind up with a fraction here. And not all problems, though, would work out as nicely as this one did. Obviously, this one was designed to work out really nice because I didn't have many fractions here, no fractions here, and everything was divisible by 3. So, you know, that's kind of an ideal problem. I can't guarantee that. Well, it wouldn't always work out like that in real life. All right, we were talking about the remainder theorem at the end of class yesterday. If a number a is substituted for x in p of x, the resulting value, p of a, is equal to the remainder obtained when p of x is divided by x minus a. And how is this going to help us? Well, we're trying to factor higher degree polynomials. So we can factor quadratic or second degree polynomials, either by factoring or by using the quadratic equation. You could even factor some third degree polynomials, but I haven't gone over that. Special polynomials, third degree polynomials that you can factor. And I don't know that it's even in our book, really. And I'm not going to go over it because really I wouldn't do it like that. Instead, what you want to do is you want to find a factor. I mean, we could just perform a bunch of synthetic divisions. We could, if you had a polynomial like this is a third degree polynomial, I could just start picking factors. X plus 1, x minus 2, x plus 2, x minus 3, x plus 3. But you know what? It might be a fraction. So just picking factors is not a very good way to do things. So what the remainder theorem does is it allows us to avoid actually doing the division, even synthetic division, before we actually know whether or not we have a factor or not. Now in a minute, in the next lesson, we're going to learn, well, what numbers do I need to try as factors? So that's where we're going. We're working on in 2.5 and 2.6 being able to factor higher degree polynomials. And we're going to learn some things that allow us to do it without a whole lot of work. And that maybe is a matter of opinion, but certainly a lot easier than it would be if we didn't have these tools. So if I think, for example, x minus 1 is a factor of a polynomial, well, all I have to do is evaluate that polynomial for 1. And if it equals 0, and I'm kind of getting a little bit ahead of myself here. Okay, if a number a is substituted for x in p of x, the resulting value is equal to the remainder obtained. Well, whatever I get from my value of 1 would be the remainder I would get if I divided by that. Okay, and that kind of takes us into, let me see what's coming next here. Trying to see my slides. That takes us to our next theorem, which is the factor theorem. And the factor theorem tells us that if p of a is equal to 0, if you have no remainder, I see how this follows from the remainder theorem. If you have no remainder, then, okay, if p of a gives you 0, or a remainder of 0, then x minus a is a factor of, that should be, of polynomial of p of x. All right. Let's look at doing a problem now. Factor the polynomial p of x is equal to x cubed plus 2x squared minus 5x minus 6 to find the roots of p of x. Now, we haven't gotten to the theorem that tells us what our possible roots are. So you're given a root. You're told here that 2 is a root, and you can verify it. And I'm going to do this on my calculator, because I showed you how to do this on your calculator right at the end of class yesterday, but I didn't really have any time, and so I didn't know if somebody might have a question here. If we turn our calculator on and we go to y equals, and let's clear out whatever we have. And if I enter that polynomial, x cubed plus 2x squared minus 5x minus 6, okay, it's going to be x cubed plus 2x squared minus 5x minus 6. Now there's two ways we can evaluate a polynomial given a value. You could go to your table and I could enter 2 right here like that. And that's perhaps just as easy, but there we just found out that, just like what the slide says, p of 2 is equal to 0. So that's one way, is go to your table. The other way is to use your vars button, V-A-R-S, vars, and go to yvars, and notice function. Now I entered my function, my polynomial, in the space y sub 1. So if I select function, here are all the possible functions that I could have in my calculator. I only have one in y sub 1, and that's the one we want. So if I select y sub 1, now I want to evaluate that function when x equals 2. And there you go. So you can do it however you want. I could evaluate that function for -3. How about that? I just found another factor. I just picked that number off the top of my head, but there's another factor, -3. All right, now let's go back to our problem, and then I'll stop for a minute and ask some questions, or let you ask me some questions. So we want to factor this third-degree polynomial. You can't use the quadratic formula. You probably cannot factor by trial and error. It would be hard to do. If I only knew one factor, we could then divide by that factor, and then we would get a second-degree polynomial, which we could then factor by trial and error, or use the quadratic formula, or whatever. So now, we are told that p of 2 is equal to 0. So that makes x minus 2 a factor. So let's go ahead and do that division. So I'm going to do synthetic division here. 2 times 4 is 8. 8 minus 5 is 3. 2 times 3 is 6. 6 minus 6 is 0. So guess what? When you divide x cubed plus 2x squared minus 5x minus 6, when you divide by x minus 2, you get x squared plus 4x plus 3. We can now factor, we should be able to, this quadratic equation, second degree. That would factor into x plus 1 times x plus 3. So now, once we have completely factored the polynomial, we can find all of our roots. When is this going to equal 0? Whenever x equals 2, because 2 minus 2 is 0. 0 times anything is 0. When x equals -1, because that would give us 0 right here, and 0 times anything is 0. Or when x equals -3. So those are my zeros of this polynomial. Remember, to find the 0 of a polynomial, you let y equal 0 and solve for x. So the zeros would be 2, -1, and -3. All right, like I said, I'll pause here for a minute and give you a chance to ask a question if you want to, and you don't have to. So I'm going to clear the hands, and if you have a specific question, you can put your hand up. Brianna from Parkway.
I was wondering if you could show us how to find the remainder of a quotient by applying the remainder theorem.
What do you mean? All right. If you take a value, a, and you plug it into your polynomial, whatever you get for p of a is your remainder if you're going to divide. Let's just look at the one that I gave you as an example. This one that we entered right here. What the remainder theorem tells us is, if I evaluate that for 4, let's say, And I'll go to my vars menu to do that. And I need to quit this first. So if I go to my vars menu, and if I evaluate that function for 4, all right, I get 70. That's going to be my remainder if I divide by x minus 4. That's what the remainder theorem tells us. We can go through that and verify that if you want to. This was my polynomial right here. If we take that polynomial, x cubed plus 2x squared minus 5x minus 6. What the remainder theorem tells us, okay, I evaluated that polynomial for x equals 4, and I got 70. What the remainder theorem tells us, if I take this polynomial and I divide by x minus 4, I'm going to get a polynomial, but my remainder is going to equal 70. So let's just do that. You're going to have 1, 2, negative 5, negative 6. And we want to divide by, a is 4, because we're dividing by x minus 4, so a would be 4. So you get 1, 4 times 1 is 4, 2 plus 4 is 6, 4 times 6 is 24, minus 5 is 19, 4 times 19 is 76, minus 6 gives us 70. There's your remainder. That's what you get when you evaluate P of 4. So what the remainder theorem tells us, when you substitute a given value into your polynomial, it tells us what the remainder is going to be. And of course, if the remainder is 0, that tells us, if I had gotten here a remainder of 0 for P of 4, that would mean x minus 4 was a factor. Now I didn't get that. I got 70. So that tells me x minus 4 is not a factor. All right. Let me see if you really, I've really gone all over everything in this section. Let's look at some of the problems in the homework, because we're really, what we got in this section is we've got the remainder theorem. Well, we covered synthetic division, we got the remainder theorem, and the factor theorem. And the factor theorem really comes from the remainder theorem. The factor theorem just tells us that, okay, if you get 0 here, then x minus 4 is a factor. That's what the remainder theorem tells us. Or the factor theorem, I'm sorry. That's what the factor theorem tells us. That if your remainder is 0, you have a factor. All right. Yeah, that's it. Let's look at the homework that you will be asked to do from 2.5. This is on page 76. In questions 1 through 5, you're just supposed to practice synthetic division, is all you're doing. In questions 6 through 10, it says without dividing, find the remainder. Well, how am I going to find the remainder without actually doing the division? See, here I did the division to find the remainder. Well, to find the remainder without actually doing the division, you're going to use the remainder theorem. So if we look at number 7, let's look at number 7. X to the 4th minus 2x squared plus 4 divided by x minus 1. All right, now you're not supposed to do the division, but you want to know what the remainder is going to be. Well, this is a polynomial right here. We can call it P of x, P of x. Okay, so all you do is evaluate that polynomial for P of 1. And whatever you get, that is your remainder. Now you can do it by hand if you want to. 1 to the 4th. Actually, this one wouldn't be that hard to do. 1 to the 4th is 1. 1 squared is 1 times negative 2. So 1 minus 2 plus 4, that's negative 1 plus 4. That gives us 3. That's your remainder right there. All I did is substitute 1 for x. Now if you want to type this in on your calculator and calculate it that way, that's fine. And we did that with the problem earlier, and I'll do it again. So if I was going to do that one with my calculator, I would type in x to the 4th minus 2x squared plus 4. And then I would go vars, y vars, function number 1. I want to calculate p of 1. And I get 3. That's my remainder. Okay, that's how you find your remainder without actually doing your division. So that's what you will be doing in questions 6, 8. Now number 10, you're supposed to do on your calculator. Let's do that one together. All right, I'm going to help you with that. We'll do number 10 here together. So if I go to y equals, I'm going to clear whatever function I have there. So let's type in that function. So it's the square root of 15. Now you need to close that parentheses right there. You don't want to take the square root of 15x to the 4th. You want to take only the square root of 15, and then you have x to the 4th. So I would suggest you do this with me right now. So I'm typing in 10 on my calculator, square root of 15x to the 4th plus 4.6 x cubed minus 0.75. And they got a 0 there. You don't have to put that, but I will. Okay, so there's my polynomial. Now, let's issue a numeric pop question. I want you to enter on your IRU. This is a pop question, not a lesson question. What would you get as a remainder in number 10? I've entered it on my calculator. I've showed you how to do it right here. Let's see if you can do this now. What would I get for the remainder when you divide that by x plus the square root of 3? All right, I've got a couple different answers coming in here, and I can see how I didn't know. I just was looking at the answer in my book. I didn't know whether it came out exact or not. It does not come out exact. So some of you rounded it to the nearest tenth. Some of you did not, which is fine. And then some of you made another mistake, which we'll look at. Let's go to Jonathan from Forest Park. Did you get the answer to number 10?
$58.
Okay. You're not alone, Jonathan. You got about, let me see here, 6% that have 58. Actually, it might be more than that. No, it's about 25% actually. Because some of you rounded 58, rounded to 258, and some of you entered 58.009. What you did, though, is, let's look at this. Let me, I don't want to show you my book because it's got all the answers in it. But this is the problem. You got the square root of 15 x to the fourth plus 4.6 x cubed minus 0.75 divided by x plus the square root of 3. Sorry about that. If you got 58, you evaluated p of the square root of 3. But see, we're dividing by x plus the square root of 3. So that means our a value here is actually a negative. You've got to remember that you're evaluating the opposite of whatever your sign is right here. So that would give you 58 approximately, but that's not correct. You have to evaluate p of negative square root of 3. And that gives you, I'll show you on my calculator. See, I did p of the square root of 3, which is what Jonathan did, and a few others, a good number of you. You do get 58.009, but that's not correct. Okay? You're dividing by x minus a. And so if you got x plus the square root of 3, that's really x minus negative square root of 3. So you're going to take the opposite of whatever this sign is right here. So you really need to evaluate your function for negative square root of 3, and this is what you would get right here. So some of you rounded it to 10.2, some of you rounded to 10.205, and that's about it. Questions on that one? Questions on number 10? I cleared the hands because some of you had your hands up to answer that question. But anybody want to ask a question about number 10 right now? So that's what your remainder would be. If you divided by x plus the square root of 3, you would get 10.2 approximately. All right. Well, let's go on now. So we've talked about 1 through 10. In questions 12 through 15, without substituting, find p of a by applying the remainder theorem. Without substituting, find p of a. All right, so what you're going to have to do there is actually do the synthetic division. You're actually going to have to divide because it says without substituting, because there's only two ways you can find the remainder. You can actually do the division, or you can use the remainder theorem, where you're substituting for x. So in questions 12 through 15, all you're doing is actually doing synthetic division again. Now, let's look at number 15. I want to look at one of these with you, the way it's written. P of x is equal to x cubed minus 5x squared plus x minus 1. And you are given a is equal to negative 2. Now, notice in number 15, they don't tell you what you're dividing by. They don't have it written as this divided by something. They tell you what a is equal to. So all you're doing here, well, actually, we're not going to use the remainder theorem, so I don't want to evaluate p of negative 2. What is it we would actually be dividing by? What is it we're dividing by? X what? Kristen from Gospel of Grace, you get the answer?
X plus 2?
That's exactly right. We're dividing by x minus a. A is a negative 2. And so that's actually x plus 2. All right, so that's what we're dividing by. But you would use synthetic division here. And so you'd have 1, negative 5, 1, negative 1. And A is what goes right here. Now, this would be important if you were actually doing the division longhand, but since we're using synthetic division, you really only need A. So negative 2. What would our remainder be? Let's issue a numeric pop question for this, and you work out number 15 right here. What would, and I don't want you to evaluate P of negative 2. I actually want you to do the synthetic division. What would the answer to this be? All right, the majority of you are getting the correct answer here is negative 31. Negative 31. So you bring that down, that's 1. Negative 2 times 1 is negative 2. Minus 5 gives you negative 7. Negative 2 times negative 7 gives you plus 14. 14 plus 1 is 15. Negative 2 times 15 is negative 30. Minus 1 gives you negative 31. There is your remainder. So that would have been the answer. Any questions on that? All right, I want to look at another problem with you. All right, David from Heritage. You got a question? Apparently we weren't connecting there. So we'll try again later on, perhaps. Now, let's look at 16 through 21. I told you what we're trying to be able to do here in this lesson is to factor higher degree polynomials. For the most part, all we could do before this lesson is factor quadratic equations. But we're not totally there yet. We still have to do some work with 2/6 to really be able to factor higher degree polynomials. But given some certain information, you can factor higher degree polynomials. If you look at 16 through 21, that's what you're supposed to do. Factor each polynomial using the given information. They're essentially giving you at least one of the factors. You have to do number 16. The polynomial is x cubed minus 3x squared minus 6x plus 8. If p of 1 is equal to 0. Well, if p of 1 is equal to 0, what does that mean? That means x minus 1 is a factor. So you have a factor right there. Use that knowledge, perform the synthetic division, and of course when you divide by x minus 1, you're going to get a second degree polynomial left over. Then you can factor that by trial and error. I'll do number 17 with you. And then I want to look at number 21 to help you with number 18 and number 20. So let's look at number 17. Q of x is equal to 2x cubed plus 7x squared plus 2x minus 3. If q of negative 3 is equal to 0. All right, so what we are told is that x plus 3 is a factor. So I know this is going to factor into x plus 3 times a second degree polynomial, a quadratic equation, which I can then factor. But I need to find that quadratic equation. And you find it by doing the synthetic division. So negative 3, and so I'm going to have 2, 7, 2, negative 3. So bring this down. That gives you negative 6 plus 7 gives you 1. Negative 3 times 1 is negative 3 plus 2 is negative 1. Negative 3 times negative 1 gives you positive 3. And there's your remainder of 0. So when I divide this by x plus 3, you get, this is your remainder. That's your first degree term, or that's your constant term, first degree term, second degree term. You get 2x squared plus x minus 1. Now, can I factor this? Because that's what we want to do. We want to completely factor it. Well, let's see if we can factor it by trial and error. 2x squared, that would be 2x and x. Last term is positive, or negative rather. So I know I'm going to have a negative and a positive. So it's either going to be negative here, or positive here, negative here. I don't know about that yet. And it matters this time because I got 2x in one place and 1x in the other place. I know my only factors of 1 are 1 and 1. So this would give me 2, and that's 1. I want the middle term to be positive, so this needs to be a positive. That would give me positive 2x minus 1x. That gives me 1x right there. So there you have it. X plus 3. There is the complete factorization of the polynomial q of x. That's what you're supposed to do. Now let's look at number 21, like I said. Number 21 says, okay, p of x is equal to x to the 6th. Now 21 is the hardest one of the bunch here, but there's something about number 21 that I wanted to point out. X to the 6th plus x to the 4th minus x squared minus 1. If plus minus I are both zeros, of multiplicity 1. That's what I wanted to talk about, this expression, multiplicity. I said 1, but it's actually a multiplicity of 2. So what does that mean, multiplicity of 2? Now we got a lot of factoring to do here because there are going to be 6 factors. But they've given us 4 of them. Positive I is a factor twice. Negative I is a factor twice. So if I was doing this one, well, let's just get started here. Your coefficients are 1, 0, 1, 0, negative 1, 0, negative 1. Because we're missing an x to the 1st, an x to the 3rd, and an x to the 5th. I know I have positive I and negative I as a factor, both twice. So let's try, let's just try I. So I'm going to get me 1. I'm going to get 1. I times 1 is I. I plus 0 is I. I times I is negative 1. Negative 1 plus 1 is 0. I times 0 is 0. 0 plus 0 is 0. I times 0 is still 0. Minus 1 gives me negative 1. I times negative 1 gives me negative I. 0 minus I gives me negative I. I times negative I gives me positive 1. Because I times I is negative 1 times a negative gives me a positive 1. And that gives me 0. I have a 0 remainder. Well, we knew that was a factor, so we knew we were going to get 0 remainder. So this is your 0 remainder, This is your constant. This is x to the 1st, x to the 2nd. But you know what? I don't even really need to go through all that. you can just take what you got here and forget your remainder and perform this division again. I know that I is a factor 0 twice. So let's just start with where we left off. Bring down your 1. I times 1 is I plus I is 2I. I times 2I is, I times I is I squared, is negative 1 times 2 gives you negative 2. Minus or plus 0 gives you negative 2. I times negative 2 gives you negative 2I. And that's going to give me negative 2I. I times I is negative 1 times negative 2 gives me a positive 2 right here. 2 minus 1 gives me 1. I times 1 gives me I. Negative I plus I gives me 0 again. That's my remainder. And I could keep going here. Now you would divide by negative I, because I've used I twice, because positive I is a 0 twice. Negative I is going to be a 0 twice. So I'd use negative I here now. And I'm going to run out of room here, so I'm not going to finish it. My point here, though, with all that, like I said, that one is a little harder than the ones you have to do. If you look at the ones you have to do in 18 and 20, in 18 you have a 4th degree polynomial. But it tells you that 1 is a 0 of multiplicity 2. So what that means you need to do is you need to do synthetic division twice using 1 both times. And so you're going to have x minus 1 as a factor, then x minus 1 as a factor again, and then you're going to have a 2nd degree polynomial, and that one you're going to have to factor by trial and error. In number 20, same thing. Negative 1 is a factor 3 times. So you're going to have to perform synthetic division with negative 1 3 times until you get down to a 2nd degree polynomial, which you can then factor by trial and error. All right, your homework for tonight, and I'm going to I'm going to change it from what's on the calendar. I'm going to make it all right, I want you to do 2 through 20 even. 2 through 20 even. I hit the wrong slide. Instead of 2 through 26. Okay, we'll change that to 2 through 20. Do the best you can with that, and I will see you here tomorrow. Have a good evening. Bye-bye.